Hello and welcome to Data Management. This is Module 1, Part 2. In this segment of Module 1, we'll spend some time discussing different types of information systems. We'll look at the role of a database management system. We'll try to come up with some kind of definition of a database. And then we'll look at databases versus spreadsheets, and finally, linking database tables together. Just as a refresher from Module 1, Part 1, as we mentioned at that time, data is being generated at an ever-increasing rate. For example, today we have over 500 million tweets sent per day. People upload over 24 hours worth of video footage to YouTube every minute. And Google receives 3.5 billion search queries every day. Somehow, we want to try and capture, record, and do something with all that data that's being collected. In this course, we're looking at data management in general. And one component of data management is the use of what we refer to as a database. So the obvious questions are, what is a database? How do we use it? Why do we want to use it? To put this into context, we can think of two different types or categories of data. One is structured data, and the second is unstructured data. Structured data is the type of data that is generated and captured through typical business operations or transactions. So for example, if you go to withdraw money from an ATM, the data that would be captured around that transaction would be things like the amount of the withdrawal, the date, the time, the account it's coming from, the PIN number that was used to access the data, and so on. That type of data can be formatted and stored in what we refer to as a relational database. We'll spend quite a bit more time on relational databases later, specifically in Module 3. But for now, you can think of a relational database as just a way of storing and retrieving data. However, much of the data that is being generated and captured now does not neatly fit into a relational database. Much of this data is things like video recordings, audio recordings, Facebook postings, tweets. That type of data does not fit neatly into the structured approach used by a relational database. In the first part of this course, we're going to focus on structured data and relational databases. Once you get up to speed on that part, then we'll relax the constraint and look at unstructured data and some of the techniques and technologies that are being deployed for managing unstructured data. To start, let's think in terms of application software. Applications that you run on your PC would be things like word processing software, spreadsheet software, and so on. For enterprise software, these are applications that can be used by multiple people, typically simultaneously. Some categories of enterprise software that are pretty common would be ERP, which stands for Enterprise Resource Planning. And that's a package that tries to manage the operations of a business that could include multiple different disciplines and functions. And I'll expand on that one in a minute. CRM stands for Customer Relationship Management. These are systems used to support sales and marketing activities. So it might, for example, allow a salesperson to record interactions that they have with a customer, the customer complaints, the customer orders, that sort of thing. Supply chain management are systems that basically track process of products through from, say, receiving them from our suppliers all the way through to delivering them to our customers, or it could be services that are also in process. And then BI stands for Business Intelligence. And these are systems which are created to take data captured from other systems and then analyze it and put it into a form that might be useful for decision making. So that might be doing something like looking at trend analysis. So an ERP system, typical ERP system, might have one module that looks after human resource management needs. So that would be things like keeping track of our employees, their dependents, the benefits they've selected, that sort of thing. We might have an inventory control system or module that keeps track of all of our work in process, all of our finished goods, all of the inventory that we have ready for sale. We might have a purchasing module that keeps track of all of the purchase orders that we've extended to our suppliers. All of the different modules are designed in such a way that they can communicate with one another so that we can share information across the modules. Some ERP systems are custom built, meaning an organization builds all of the software internally from scratch. Some ERP systems are purchased in a manner that is referred to as best of breed, where a company might say, okay, let's find the best human resource package available from a vendor. And now let's go to a different vendor and find the best inventory control package we can find. And now let's link them together. And then a third approach might be to buy an entire ERP system from a single vendor. And that vendor will provide all of the modules that we need, and they're already built so that they will communicate and link together quite seamlessly. Building it by yourself or custom built can allow you to build it in such a way that it closely matches the needs of your organization. However, that approach can often take longer and be more expensive. In addition, you have to constantly be updating that software as your needs change. Buying the best of breed approach, you can run into challenges where there might be incompatible systems, and you then have to build some software so that those two modules can communicate together. In addition, you're going to be working with more than one vendor, which can get a little bit of a challenge. We won't go any further into the different approaches to buying different software at this point, but just to recognize that there are different ways to acquire those applications. But now let's take a look at the role of the database management system, or database. Every ERP system has to have a database management system for it to operate. Same thing with customer relationship management system, supply chain management system, and so on. The idea is that the application, like the human resource module of the ERP system, it captures and stores data, but it does so through the assistance of the database management system. Essentially, the database management system takes care of all the data management needs for that application. In this particular diagram, the term database is used. So I've got the question here, what's the difference between a database and a database management system? And the answer is, this is where the definition of database starts to get a bit messy. For some people, the term database management system refers to the software, and the term database refers to the store of data which is managed by the database management system. For other people, they use the term database to encompass both. The database management system and the store of data called the database, they put them all as one thing. And that's why definitions for database get to be a little bit messy. And I'll expand on that a little bit further. But first, let's think in terms of desirable attributes of the data that we capture, store, and use. We want it to be shareable so that multiple people can access it at the same time. We want it to be transportable so it's easy for people to access it who need it. We want it to be secure, so it's going to be protected from unauthorized use or destruction from natural events or whatever it might be. We want it to be accurate. Now, we should mention that accuracy is a relative term, meaning if we're talking about something like my bank account, I want it to be very precise. If we're talking about something like sensors for weather forecasting, maybe a little less precision is okay. Timely, which means it's current and up to date, again, that's a relative term. What's timely for some application may be more necessary or more timely than for another one. And then relevant. So we want data that's going to be appropriate for whatever decision we're trying to make. Whether we're trying to forecast the weather or we're trying to diagnose a patient's illness. So as I mentioned, the definition of a database is a bit of a challenge. So here are three that I've listed, drawn from different sources. Comprehensive collection of related data organized for convenient access on a computer. Okay, that one seems to focus on the data piece. Database is a data structure that stores organized information, usually in multiple tables. Okay, now we're getting into a little bit of how it's done. And the third one, a database is an application that manages data and allows fast storage and retrieval of that data. Well, here on the application side, it sounds like they're talking about the software, whereas the first one was talking about the data. So you can see why it's a little bit of a challenge. Depending on what source you go to, you're going to find different definitions of the term database. The only reason I wanted to mention that is because when you're talking to people and they talk about databases, you might want to clarify with them exactly what they're talking about, because your understanding of what a database is may be different from the way they use that term. To try and frame this a little bit, let's try and keep track of, or keep in mind, why we have a database in the first place. And the purpose is simply to help people keep track of things that are of interest to them. Simple as that. I might want to keep track of customers, or sales, or inventory, or weather events, or whatever it might be. The database is going to help me keep track of that stuff. It's going to help me capture information, store information, and manipulate that information. In a relational database, and that's what we're going to talk about now. Later on we'll talk about other types of databases, but for now when we say database, we're thinking in terms of a relational database. And in a relational database, data is stored in tables, and you can think of it like a two-dimensional array. They have rows and columns just like a spreadsheet. Typically a database will have multiple tables, and each table stores data about something potentially a little bit different. And again, we'll expand on that in much more detail when we get to Module 3. Each row of a table stores data about a specific instance of the thing of interest. So if I've got a customer table, every row in that customer table is going to represent a single, unique customer. And the information about a customer will not bleed over onto two or more rows. All the information for that customer will be maintained in that row for that table. Now here's the big difference between a database and a spreadsheet. A spreadsheet stores data. You can store data in a spreadsheet. However, you can't easily store relationships in a spreadsheet. Now this will probably not be too apparent right away, but once again when we get to Mod 3 and take a look at the relational data model in more detail, hopefully that will become quite clear. But this is one of the major differences between a spreadsheet and a database. You can store data and relationships in the database. Okay, so here's a bunch of data. It's just sitting there, not very informative. Now we've organized that data into a form that hopefully will make more sense. Now we can see we've got a customer data table, or a customer list. For each customer we've got the name, street address, city, state, and zip. And as you can see, each row represents a specific company. So we've got Krispy Kreme donuts, we know where they're located, what street address, and so on. Let's take another example, only this time we've got multiple tables. We've got a student table, a class table, and a grade table. Each row or record in the student table represents a single instance of student. So we've got student number 100, Student name is Cook with the email address. Each record or row in the class table also represents a specific instance of class. Now we've got this third table called grade, and we have some entries in the grade table. How meaningful are they? So the first grade says 3.7. Okay, but what does that mean? What student or course or combination does that represent? The way we've got this presented right now, it's not very informative. Okay, now we've added two columns of data to the grade table. We've added the student number and the class number. Now if I take a look at that 3.7 listed in the first record, it makes more sense. I can see, okay, student number 100 took class number 10 and received a grade of 3.7. The way this is designed, if you take a look at the student table, each student number only appears once. The student number is unique. It uniquely identifies a student. Same thing with the class number. Each class number is unique. It only appears once in the class table. It uniquely identifies an instance of class. In the grade table, student number can repeat, or class number can repeat. However, the combination of student number and class number does not repeat. In other words, student number 10 is only associated with student number 100 is only associated with class number 10 in the very first row. And that joining of those two does not happen again. We'll spend much more time on this later when we get into the relational data model. But for now, just recognize that this is how tables can be linked in a relational database. We have a situation here where we've got a student can take many classes. A class can be taken by many students. The way we link those two together is through our grade table, where we've got the combination of the class number and the student number to identify the grade the student achieved in that particular class. As I mentioned, this is just a brief introduction to this topic. We'll expand on that in much more detail later. That is the end of Screen Capture 2. It is also the end of Data Management, Module 1, Part 2.